These are renal corpuscles. Renal corpuscles are only found in the cortex of the kidney. You might remember that from A and P. And then when you get down into the medulla, and here's the border here between the cortex below and the medulla above. The medullary area, the renal pyramids, do not have any renal corpuscles. Okay? So these are simply tubular structures, either collecting ducts or loops of Henle that are extending down into the medulla all the way down to here, the renal papilla. But let's look, for instance, at some of these structures here. All right, here's a duct or tubular structure. There's the lumen at the tip of the arrow. Let's go higher power. So here's one tubule right here. What type of epithelium is this? Yeah, that's simple cuboid. Now, the fact that we can see cell membranes here that separate cells, if you remember from A and P, this tells you this is the collecting duct. In fact, the collecting ducts get a little thicker as you move down toward the renal papilla. So you can see that the cells are going to become a little bit more columnar as we move toward the papilla. These are just, this is instead of a longitudinal cut, this is more of a cross section or a oblique cut through the collecting duct. Move it in the center and take a high power view. Okay. You can see that toward the papilla, these cells are becoming more elongated or taller. So the collecting duct develops a simple columnar epithelium as it begins to empty through the papilla. So we see renal corpuscles here, so we know we're in the cortex. Let's go a little bit higher power. Someone mentioned Bowman's capsule. Bowman's capsule is this capsule here, with the lumen here surrounding the glomerulus. Now, this outer margin of the capsule here is the parietal layer of Bowman's capsule. You can't see many nuclei, but that's one. That's the Bowman's capsule. The lining is a simple squamous epithelium. There's one squamous cell. There are others here. This one's not so easy to see. Here's one. Here's one. So Bowman's capsule is lined by a simple squamous epithelium. But these structures that surround the renal corpuscle, these are renal tubules. For example, here's a cross section through the proximal convoluted tubule. And here's the lumen, the cells that surround it, that make up the wall, are simple cuboidal epithelium. Again, PCT here, simple cuboidal epithelium. Simple cuboidal epithelium. If we find a DCT, see one. This might be a DCT here, it's not a way. But this is also a simple cuboidal epithelium. Now, the PCT have microvilli, but it's not as nice and well organized as the microvilli that you see within the small intestine. It just kind of looks like a raggedy apical surface. Not as nice. You can see it better under electron microscopy. let's look at some of the slides that Victoria had here. Now, here's a structure here that has a lumen. This is a space lined by a lining epithelium. And you can see that the lumen is somewhat collapsed, kind of star-shaped. What type of epithelium is lining that lumen? What is it? Is it keratinized or non-keratinized? Non-keratinized. So, what type of structure do you think? What type of organ is this? Do you know? It's the esophagus. We said that for stratified squamous, we use that mnemonic, say skin, anus, vagina, esophagus, and mouth. We know it's not the skin because it's non-keratinized, meaning you can see nuclei all the way up to the surface. These are not dead cells. They're maintained their nuclei. So it's got to be either anus, vagina, esophagus, or mouth. Okay, it's got to be one of those. Okay. Of all of those organs, the only one that we really looked at under the microscope in A&P was the esophagus, and that's what this is. Now, what do we call? This is the epithelium, the lining epithelium. What is this region called? Right underneath. What is the name of the connective tissue upon which the epithelium sits? The lamina propria, right? And so, this is the lamina propria directly beneath the epithelium. What is this structure right here? Can you see? It's a blood vessel. If you look closely, there's a simple squamous epithelium that lines the lumen right here in the center. And so that would be called an endothelium. But here's another little blood vessel. Right here. Now, if you see red blood cell ghost, it makes it easier to identify as a blood vessel, but in this case, this is kind of a classic appearance, so even without the red blood cell ghost. And you can barely make out some red blood cells in there. That's a blood vessel, that's a blood vessel. Now this one's more elongated. This is a venule. They tend to be more collapsible. This is a small arteriole. But again, simple squamous epithelium. Here's another blood vessel, simple squamous epithelium. Once you kind of have identified a few, you begin to recognize all of them. Here's another one. This is about the size of a capillary. In other words, this can only accommodate maybe 1 or 2 red blood cells. Now, you see that some of the tissue, some of these fibers here are more refractile. Do you see that? In other words, they reflect light a little bit more. Those are elastic fibers. Hence, the elastic fibers within the lamina propria that contribute to the collapse of the lumen when there's nothing traveling through the esophagus, when there's no food. It contributes to the elasticity. Oh, so let's go back to that same slide. We said that is non-keratinized stratified squamous. And notice that when you reach the surface, that when you have a stratified squamous, the cells along the basal surface may be more cuboidal, but they flatten out. See how they're flattening here? But you can still make out nuclei here, here, all the way to the surface. So that means this is non-keratinized. See another big old space here, lined by a different type of epithelium. Let's look at this now. Can you tell what type of epithelium this is yet? Yeah, this is pseudostratified. So, the esophagus and trachea are right next to each other. The trachea is more anterior, the esophagus is posterior to it. So, they can take a slice through that section of the mediastinum and pick up both organs, both the esophagus and trachea. And the cilia, these are cilia that line the apical surface, they have a more scraggly appearance than does a brush board or microvilli. Now, on a light microscopy, it looks like simply a bunch of nuclei stacked upon each other. But remember, with this type of epithelium, each of these cells actually comes all the way down to the basement membrane. Here's a little basal cell here. This is probably a stem cell. There's several of those. Okay. What do we call this layer that's deep to it? So if this is the basement membrane here, this is where the basement membrane will be located. What do we call this underlying tissue?